Should crank up the sound so we can hear him chattering in the background. It's very interesting what's going on. Okay. All right, guys, they heard me say that too. I had my microphone on already. We were talking about spying on you guys in the background before I turn off before I mute everybody. Can you see my screen and hear my voice? I presume you can. Okay, so I'll be posting a homework later on tonight. That homework will basically consist of at least one calculation that you need to do by hand. Most likely be a simple chi-square calculation. And an example of using SPSS to calculate the t-score. Might be equal variances, might be unequal variances. Using SPSS to calculate a chi-square, and using SPSS perhaps to calculate an analysis variance. I might simplify some of this stuff by just giving you a table and asking you to identify the parts of that table. For instance, when we did analysis of variance, I closed SPSS, I think. When we did analysis of variance, for instance, analyze. Let me see if the output window is still. No, I closed the output window. When we did analysis of variance, that means the output window, for instance, this output window showed a number of things. It showed, well, the numbers between the sum of squares between the groups and the degrees of freedom. You'll notice that the mean squares is just the sum of squares divided by the degrees of freedom equal to the mean squares. Within the groups, the mean square is just the sum of squares within the groups divided by the degrees of freedom. 15 groups minus 3. 15 subjects minus 3 groups is 12. So 25 divided by 12 is 2.5. And that's where those numbers came from. And then the F score just came from 8.6 divided by 2.1. So if I left out the degrees of freedom, you would be able to tell me it must be 2, right? Because this was 17.2 and this was 8.6. So this had to be a 2. So if I left out the degrees of freedom within the groups, you would be able to tell, because if the 12 is missing, you would have known that it had to be 12, because that's how you get 25 over 2.1. You can just divide one into the other and get 12 and realize that, right? Just so and then, like, if I asked you what's the probability of an alpha error if you reject the null hypothesis, well, that's what the p-value is, the significance is. Chances of being wrong if you reject the null hypothesis of making a type 1 error is going to be 4.4% or 0.044. Right? So I might ask you, I might give you tables like that, maybe for chi-square also. You'll also, you might want to look through the PowerPoints, because I may ask you certain of these things. There's certain kinds of assumptions that are important. For instance, when you do a t-test using proportions, you want to make sure you have at least 15 in each group. Okay, that also allows you to use the z-score, so it's a nice thing for us. But you can't have, for instance, you can't do the t-test if I told you have a sample of 100 people and 10 of them had diabetes, and another group you had 100 people and 27 of them had diabetes. You got a problem with the first group. 10 of them have diabetes, 90 of them don't. The 90 is good, but you don't have 15 on both sides of that. Right? You got to have 15 on both sides of the proportion in order to do a t-test for a proportion. Right? Not so much if you're just doing it for samples or paired samples, then you can do it for any size you want, right? But if you're doing it for sample sizes less than 30, you're going to have to make sure you use the t-value instead of the z-table. Okay? SPSS will do it for you automatically, right? So you don't have to worry about it. But if you do it by hand and you calculate a t-score, a score, that scores, if it's smaller than 30, a sample size smaller than 30, that's going to be a t-score. So you have to compare it to the critical value of t. If it's bigger than 30, a sample size, well, then you can call that a z-score and either compare it to 1.96 to decide whether to reject the null hypothesis, or actually go to the table and figure out what the p-value really is. Okay, so that's the kind of thing you might run across there. So now, so I'm going to post the homework. That'll be a good exercise for us. As you know, I let you go back and redo the homework, so don't get nuts about the due date. I'm going to make an imitation due date of the homework for this homework of Sunday because Monday's the test. But on Sunday, I will go over it so that we go through the problems and you get kind of a picture of how to deal with those problems if they appear on the test. It won't be exactly the same as on the test, but you know. Now, keep in mind, don't freak out because one of the things we've done here is everybody has or still has the opportunity to basically get 100% on the homeworks if they want it, right? And most of you guys did pretty well on the first test, right? And the interim test, unless you did badly on the first one, it's no difference at all. So you're in pretty good shape, right? Now, obviously, I can't get everybody in the class an A plus; they'll throw me out of the building, right? So this is going to be a little bit harder, and the project's going to be a little bit more rigorously graded than we've done before. But now you got a nice buffer, right? Uh, uh, so all of us are going to be around next semester. Basically, is what I'm saying. Just all you need to do is make sure you keep up with the work, and you go ahead and like put your best into this thing, and I'm sure it'll work out well. But don't expect that this test's going to be quite as easy as the first one. If for no other reason, the material is more challenging now, right? You have a lot of different tests, a lot of different ways this could go. I think it'll be kind of somewhere more like the interim test with some calculation and some questions and so on and so forth. But I don't think anybody's going to leave it before 2 hours, put it that way. So I think it'll take you a little. The first test, a lot of people, there were some people who were starting to bail out like about an hour and a quarter in or something like that. Right. So this test will take you a bit longer, I think. I could be wrong. So that's the hardest thing for me to ever estimate. Ever tell you about first time I taught this course with Susan Klitzman? She gave the first test she did. She gave a test that was like after about 5 hours, I was still sitting there with students that weren't finished yet, and she bailed out. She had to go up to her office and do some advising or something like that. I'm sitting there with students struggling for 5 hours. So it really is hard to judge, whether or not you made a test too long or not. But we'll figure it out. It'll work out okay. Okay, but do your best to figure out when you need to do. Now, reason why I'm doing this test this way is because this test is going to force you to focus on how do you do it, when and how do you apply a t-test? When and how do you apply a chi-square or odds ratio? When and how do you apply analysis of variance? Why is that important? Well, the reason why that's important is if I go into Blackboard now, hopefully it's still there. Oh no, closed. Oh, I think it's working now. Oh, it's working again now. Okay, Blackboard's up again now from the normal way again. If I go into Blackboard now, I go into our project section. There's our project section, final project. You'll notice that at this stage, I've given you two groups of data that you can work with. I'll be adding to that. I'll be giving you some other data sets. One data set is from the New York City Community Health Survey. You can click on this. You can click on this. I'm going to open this in another window. You can click on here, and you can actually go to that site. Oops. I just put that link in here today, and then I'll work it. And why is they're coming and then going? Okay, I'll do it this way. New York City, I got to put it in here. New York City Community Health. There we go. There we go. On the health. Oh, no, that's not what I want. Let me try this. First of all, let me go to Google. Maybe I'll put that. I'll have better luck there. New York City Community Health Survey. There we go. Okay. Why is it doing that to me? Let me try a different browser. I think it might be the browser. I'll broach the issue of why Yahoo seems to have seems to have hijacked my browser. Survey. Try this. There we go. Yeah, it was the browser. Okay, so now I can go into here and I can take a look at the actual data itself that's available. Okay. Now notice I have data for all these different years. The most recent data that they've accumulated, it takes them a while to do the survey, to collect all the data, to summarize it, put it into a usable form. You have actually a copy of the questionnaire that they used. Okay. Here's a copy of the questionnaire, the questions that they actually asked, and all the different options that you have for the questions. You also have a copy of the code book. Well, what is the code book? The code book is a description of the data file, and it tells you for each variable. Like, for instance, there's a variable called Insure 5. Well, what is that? That's the type of health insurance, right? And Insure 5, if you see a 1 there, it means private, a 2 there means Medicare, 3 there means Medicaid, 4 means other, and so on and so forth. Okay, and you can use this data as is, or you can reformat it in SPSS. Oh, actually, maybe on Sunday, maybe I'll wait till after the test to show you how to reformat it, so I don't drive you crazy. I'm driving you crazy enough with this. So I'll show you how to reformat it, so that, for instance, you could change all these different groups into just insured or not insured, right? Just 2 values, right? Or get rid of all these other, just compare private, Medicare, and Medicaid, or something like that. So I'll show you how to reformat the data. But this gives you a description of what each one of these data, what each one of these variables represents. Some of them are numerical variables. There's diabetes. One, yes, I have diabetes. No, they don't have diabetes. And this is, they have 1,000 people, 7,600 people, number of people that actually responded to this, okay, and what categories they were in. During the past 30 days, how often did you feel nervous? So you have a mental health, you have a number of variables that give you a measure of the person's mental health. There's variables in here that represent how much fruit somebody ate, variables that represent whether or not they got flu shot, variables that represent so on and so forth. Average number of sodas plus sweetened drinks that that person would drink. None. See, this is category, even though it's if they're asking about the number of drinks, they're putting into the categories. Right? It's really categorical variables. But there are some that are numerical variables. And so I think they ask age, they ask weight, and so on and so forth, height, weight, that kind of stuff. I believe there are a bunch of numerical variables. But we'll take, so the code book describes each variable and what that number represents. So you can go into SPSS and code it. So let's take a look at the actual data file itself. So the actual data file itself, I'll get it from our page rather than there. Okay. Okay, here's the actual data file itself. This is the entire one. Okay, just save. I think I saved it to the desktop. And I'm going to open SPSS. I'll open that file. Open data. And let's see. Go to the desktop. And there it is over here. Open this. Okay, now it's a little intimidating when you first open it, because look at all the fields you have here. But now we know that each one of these fields represents something, right? That represents something that we can actually look up in the code book. This is the borough. That obviously there's 5 values in here. This is the borough the person lives in, right? So now all you have here are numbers. You would have to go into the variable view for borough, find borough here somewhere. Here's borough, and you would have to tell it that the borough, that the number 1 represents Brooklyn, for instance, and you would get that from the code book, right? And you could add that in there, and then from then on, whenever you did a analysis, it would use the actual name and so on and so forth, whatever it actually has. You actually, in the labels here, you have borough of residence based on so on and so forth. That's going to print out on your table or your graph, right? You might want to simplify that. So what prints out on your table or your graph is just borough. Right? Seems simple enough, right? Or you might make it more or less descriptive. Right now, it says what the question. It says what the question was. Okay, and you can actually search through this to find a whole bunch of variables. Like for instance, I'm not gonna do it. Yeah, I would do it in the PDF file. I would search. If you're interested in something about sugar, maybe search the PDF file that's the code book for sugar or other things, or just go through it. Go through these variables one at a time in the questions and look for something that's interesting to you. There's 209 variables in here, 209 questions that they had these people answer in this survey. Okay, so now I'm going to go back to the data view. Now let's say you decide, I'm going to use this variable and this variable. It's a categorical variable. That's all I need. I'm just interested in comparing, and whether a person's insurance status is to how much fruit they eat or something like that. I think there's some association, right? So you might only want to use those two variables. You might want to use three variables or four. You don't need all the rest of them. So you could actually highlight these things and say, cut them out, clear them out. Cut it. So you can abbreviate the data file. And we did that here to give you an example, like this one over here. Put it down, save link as, I'll put it on the desktop again. This is a simplified version. And by simplified, all it means is that we've eliminated it. So we don't mean that you need to use that, but just as an idea as what it'll look like if you simplified this database and just keep the variables that you're interested in working with. See, it's the same data, except now I'm only working with 10 variables that I kept, right? Race, demographics. What does demographics mean? What's your age? Right? That happened to be age. You highlight it, it spreads them all out. If you don't highlight it, it only spreads out the one you want. Borough of residence, race, ethnicity, whether you're insured or not, type of health insurance, so on and so forth. Gender, right? Were you born in the United States or outside the United States? Number of children, that kind of stuff. So here you have like an example of 10 variables. Right? Maybe you're interested in them, maybe you're not. Maybe you want to find some other ones out of the other 200 that you have available to you. Okay, so that's really what we're dealing with here. So now, if I look over here, only one of these is a scalar variable, something we can do means with, right? Which one is it? It happened to be age in this case, right? So in other words, if I wanted to go borough by borough and compare the average age for people in each one of those boroughs, how many boroughs we got? 5. So we got, what kind of variable is boroughs? It's a categorical variable. What kind of variable is age? Numerical variable. What analysis should I use to compare the means of those 5 groups? Means of 2 groups, you use t-test. Means of multiple groups, you use. Now, so I would literally go in here, analyze, compare means, analysis of variance, and I would go in here and let's put our age into the actual dependent, the actual numerical variable, and I would put, where's borough? Neighborhood. Is that it? Neighborhood? Am I right? Oh, yeah, you're right. It's the top. There it is. I see it. We put borough into there. And let's see what happens. It's going to run an analysis of variance. Okay, does it look to you like there's a difference in the average age for at least 2 of those boroughs? Sure does. Right? That's a big value that we got. Let's see what the difference is. Analyze. Yeah, it's enormous, yeah. Okay, one-way analysis of variance. Let's do a post-hoc test this time. Let's do both of these. So what do you think is the oldest average age borough? Take a guess before we do it. What do you think the oldest people are in New York? Huh? Anybody got a guess? Come on, who's the youngest? Put it that way. I'm thinking Manhattan, right? The youngest, right? No, come on, guys, awake or not? What do you think? You're public health people, right? You must have an opinion. Right? I'm thinking Manhattan's the youngest. Let's go ahead and do this post-hoc test. Okay, let's see what we got here. Let's see, the mean age. Let's see. Let's see if we get the mean difference. Actually, what I should have done first is, let me go back here. Analyze descriptive statistics, explore, and I'm going to move age into the dependence list. I'm going to move borough of residence into the factor list. That's not asking me anything. Okay. For statistics, okay, it's going to do descriptiveness, but let's see if it does anything for me now. Okay, the mean for borough 1 is 47, 46 for 2, 52, 48, and 52, 51. So the oldest is borough number 3. We'll look that up in a second. Okay, borough number 3. But now we have to determine which of these are really different from one another, if there's a real difference between each of these means. And that's what we do the, and you could also take a look at your crosstabs to see if you see a difference, right? You could also take a look at your, I didn't bother to check off to do a histogram, right? But I can kind of see it here. You could determine if they're normally distributed. Okay, so let's take a look at analysis of variance. What do we get for that? A post hoc test? Let's see. Let's see if we have significance. Well, borough number 2 and borough number 1 are not significantly different. Borough number 3 and number 1 are significantly different. And borough number 5, 4, and 1 are not significantly different. And borough number 5 and 1 are not significantly different. So the oldest one looked like it was number 3. Let's take a look in the data files to see what number 3 was. We're just gonna take a look at that, and then we'll say goodnight. And I'm gonna take a look at the questions online before I hang up, because I don't want you guys to feel neglected. Okay, let's see, borough. All right. I seem to have gotten a problem. Okay, borough. There is borough. There it is, there's borough right there. And borough number 3, Manhattan's the oldest. I was completely wrong. I would have thought they were the youngest, right? Had the most young. No, I said that they were the youngest, right? Because I know a lot of young people that, 3 to an apartment in Manhattan, right? 3 or 4 to an apartment in Manhattan. I would have said that they were the youngest. But in fact, they're the oldest. So I guess that's, instead of going to Florida, you move to Manhattan, right? If you have money. If you have money, you move to Manhattan. If you don't have money, you move to Florida after all, or Arizona. Yeah, well, that's what's going on here, isn't it? In other words, the differences between some of the boroughs are very small, the average age. But the difference between borough number 1, between the borough of the Bronx and the average for Manhattan, is big enough for you to be sure that there's a real significant difference, that it's not due to chance, due to the sampling error. Yeah, and borough number 1 and 5 was significantly different. That was the Bronx, and that was Staten Island. Okay, to be honest with you, that's what you're going to do in your project. You're going to go in here and you're going to look at this data and try and pull out what this may mean. Why is that taking place? Is it that, like, there's the bulk of the rent-controlled housing is Manhattan, so they're stuck there, they can't move? Or does it mean that there's newer stock of housing in Staten Island, so probably younger people, right? What does that, what does all this mean when you do these analysis? Okay, so we'll talk more after the exam about I'll give you some more data sets you might want to play around with, and so on and so forth. Do me a favor, if you happen to wind up doing something like data-wise that is the same kind of analysis as the demonstration ones, one of the 4 that I gave you, don't just copy their analysis. Don't, do your own work, right? And if you can find some fresher data or something like that, see what you can do with it. And a certain amount of this is going to be, is going to be, like with diver, like when they do diving at the Olympics, right? It's not just, doing perfect dives. Certain level of difficulty, you get a little bit higher score. So if you do something really simple and basic, if you do it perfectly, that's nice. But if you do something a little harder, it's a little higher level of difficulty. We'll keep that in consideration. Right? Do something interesting. Pick out something that's interesting to you. Because if you pick out something that's interesting to you, even if you have to dig a little bit for data, and I'll try and help you with this if you need me to, then you'll be more invested in it. It'll be a lot more fun for you. Okay, so tomorrow night we'll go over exam one. Saturday or Sunday I'll post a link. We'll go over prep work, the homework that I'll post. What's that? Yes, I will. Yeah, I'll finish them up. I know that's a Blackboard thing. I know you can't even go back and look at the stuff. It locks you out until I grade it. And you want to know something? The only reason you don't see it immediately because there's one question where you had to upload a document, and it won't let you see it until I grade that document. That's what the problem is. But I'll make sure I get to that. Okay, guys, online. Let me see if there's any questions. You guys say good night. Can I? Yeah, sure, absolutely. Poverty level insurance, it's perfectly legitimate. So if it's less than 0.05, it means that there's less than 5% chance of being wrong if you reject the null hypothesis. Okay, let me see. Exact subjects. On the exam, t-test, chi-square, and analysis of variance. We need to get the topic again. Yes, you should be going to the link on Blackboard. You'll notice on Blackboard there's a link for picking out a day and time when you want to present, but there's also a tab there for your presentation topic. Right? Let me go back to Blackboard. If you look down here, you look over here, presentation date and presentation discussion board. And in the presentation discussion board, right, you can pick either if you're in the group A, the Monday group, or the group B, the Wednesday group, just click on that and you can post there what you plan on doing. Some people have already started doing that. You can post what's there, what you're doing, and then other students can click on that, read your post, and make suggestions. You can even put data there. You can even upload a graph or something like that. Other students then can click in there and they can criticize. Here, so here's a student that's done a little bit more work on it, and now I can go in there and reply and say, gee, I think that's a really great idea, or I think you're painting yourself in the corner. Maybe you should trying it from this perspective or something like that. And it'll be listed here, and then someone else can reply to that, and so on and so forth. So you can you can have peer-to-peer feedback. Each of you can help each other do that. And I'm going to be checking this to see who's active on these boards, right? And that'll help your participation grade. Okay, but certainly you should post what you plan on doing, because even among the other students, I'll be looking at that and I'll be able to say, gee, that looks like a good idea, or boy, that looks like a fantastically bad idea. So I think you should try something else or something like that. So maybe I could save you some work going, painting yourself into a corner or going off on a tangent. Through email, post them on the. You can post them on the. I would prefer you to post them on the discussion board. If you're really shy, you can email them to me. Okay, but I mean, it's an advantage to post them on the discussion board. You get some other feedback. So poverty level with type no poverty analysis of variance. You need numerical variable. So poverty level is going to be like a category like 1, 2, 3, poor, medium. I don't think it's going to be a dollar value. If it's a dollar value, an income, family income number, then that's numerical, and you can break it up into groups of have insurance, don't have insurance, Medicare, so on and so forth. If it's a categorical variable, like you have insurance or you don't have insurance, and you're looking to see different poverty levels where they have insurance, those are categorical variables, both of them. So you need to do chi-square or odds ratio. For if you actually had the incomes, and that's the way you were defining the poverty, what their level of poverty was, then you can find the average for people with average salary for people with insurance, people without insurance, people with Medicare, people with other kinds of private insurance, so on and so forth. And that you would use either the t-test if there's only 2 groups, or analysis of variance if there's 3 groups. Okay? Okay, guys, good night. Thanks for tuning in. And we're on the home stretch here, right? Next week, Monday, we got a test. Wednesday, we got a class. We're going to talk about regression, and we'll spend about half the time on regression and correlation, and the other half we'll spend on working out any issues with the projects. And then next week got the projects, and then we're all done. You have all of the end of July and all of August to spend at the beach or go to the Met Games or whatever you like to do. So good night, guys.